This video is entitled Logical Data Model and goes along with Chapter 6 of the book Introduction to Database Systems, Modeling and Administration by Dr. James Reneau, and that's who I am. Nice to have you here, and I hope that you learn something as we go through how to create a logical data model. So in the previous videos and previous chapters of this book, we've created a conceptual data model with our entities and some cardinality and relationship information between the entities in general. We've added in the last couple of videos, we've created our entities in the logical model, added attributes, and identified their primary key or a unique identifier for each instance of an entity. And now we're going to connect those entity boxes with their primary keys together by creating relationships. We're going to use something called a crow's foot, where the slide there says crow's beat to show. It should say crow's foot or feet to show the cardinality between the two boxes. Foreign keys, which we're going to add, are how we actually make that connection. We'll eliminate many to many relationships, and we'll talk about what those many to many relationships are. And then we're going to talk about how to implement specializations and generalizations in a logical data model, which again is a more higher fidelity model than a conceptual model. So we're going to be including more details about the data than we did in the just general conceptual model. The type of diagramming that I like to use for a logical data model and is used by probably majority of data modelers is known as the information engineering or IE diagram. It's also known as the entity relationship diagram, and there are several different ways to draw ERDs. There's the Chen model and other models, but this, if you understand how this model works and how we're laying out the model, laying out the data, understanding the data, and creating this type of model. I think if you ever have to be in a position to use a different type of model because of your employer's dictates or your professor's dictates, that you'll be able to move into that other kind of model. So we're going to be using these IE models and IE shapes for our logical model and our physical models. We'll also, the entities with attributes came from, again, the previous chapter. And then we're going to learn how to draw these crazy special lines that define the cardinality of a relationship. In an IE entity relationship diagram, we have these things we call crow's feet, and they replace the arrowheads on the both ends of our arrow and define the cardinality. Just commit these four shapes, these four crazy shapes to memory and commit their definitions. But when you look at them, you should be able to see, for instance, the first one, it's two bars, one and only one. So the two bars say one and only one. The next one says 0 or 1. Well, that kind of makes sense. Look at the shape. It says 0, 1, 0 or 1. On the third shape, it's 1 or more with the greater than symbol. So you can see that it represents 1 or more. And then the last symbol represents 0 or more. So by just looking at the shape at the end of the arrow, looking at the shape or the crow's foot as we call them, you should be able to very easily see what the shape means. One and only one, 0 or 1 or more, or 0 or more. So here's an example of two entities with a relationship between them. uh, let's think about our pets. Let's think about our animals that we share our lives with, our pets. So we have an entity that describes each animal. The animal, we're going to assign each animal a unique identifier because maybe this is part of a veterinarian's database or part of a pet store's database. That makes sense, wouldn't it? So we have an animal, and each animal would have a unique identifier. The animal would have a name and a gender and other things, but each animal would also be a member of a species. So the species entity would be a categorical entity that just contains categories like D for dog, C for cat, H for horse, um, B for bird, X for axolotl. I don't know. You could, or maybe the species code would be an abbreviation of the Latin. So C for canine, dog, F for feline, cat, E for equine, horse, however the veterinarian or however the customer wants to set that up, and however they want to, whatever kind of descriptions they want to use, and whatever they want to use as their abbreviation of the species ID. And then we have the relationship drawn here with this crow's, with this arrow, with this line with the special ends. And I've added a description member of, so that we can say an animal is a member of a species, and a species has members of animals, of a specific animal. And the diagram with the crow's feet can be read as follows: an animal is one and only one species. A species can have zero or more animals. So read that. An animal has one and only one species, and the species can have zero or more animals. For instance, in our veterinarian's practice, it's a cat, it's a dog, it's a horse. It can't be dog cat, cat dog, like the crazy cartoon many years ago. It can't be cat dog. It's got to be a cat or a dog. Maybe we have a species code set up for a horse, but we don't see horses in our practice, but we might someday. So we might have a species code for a species that we haven't seen yet. So there you can see the relationship from species to animal could be a species has zero or more animals connected, but an animal is always connected to one and only one species. Here we get into a little bit more complex logical data model. For instance, customers buy parts, right? And a part can be bought by many customers. So, but in that relationship, there's something between a customer and a part, and that would be an order. A customer places an order for a part, and a part is on an order. An order can have multiple parts, and a part can be on multiple orders. So let's look at the relationship now. We've got the customer entity, we've got the order entity, and we've got the part entity. We've got identifiers, our unique identifiers, our primary key defined for customer ID. Our order contains an order ID, and our part database, our part table, part entity contains a part ID. And then our connection is that a customer has zero or more orders, and an order is for one and only one customer. Well, that makes sense. Customer places an order, but an order is for only one customer because it'd be confusing as can be if we had an order for multiple customers. Why is it a customer can have zero or more orders? Well, what happens when we get a new customer and they haven't placed an order yet? Maybe we've got a prospective customer and we want to go ahead and put them in, track their name, their email, their phone number, assign them a salesman maybe, or something of that sort. But they've not placed an order yet. You got to register before you can place the order. So when you register, add them to the customer table entity, and then we'll have an order. maybe very quickly, it might be simultaneous, but that's why I put a zero there. If your business rules say a customer cannot exist if there is not an order, they have to be put in at the same time, then you could have drawn that as a one or more instead of a zero or more relationship. So a customer is may place zero or more orders, but an order is for one and only one customer. Now let's look at the relationship between orders and parts. An order really can't exist without a part on it. Just makes no sense to have a customer place an order without parts on the order. And vice versa, a part can be on zero or more orders. Maybe we've got parts in the warehouse and the inventory that we've never sold yet. That's not a good thing. We need to figure out a way to get them sold. But at least initially, they're in the inventory before we sell any of them. So you can see the relationship between part and order is a special kind of relationship we call a many to many relationship. And we'll talk about that in more detail because they're not so good. But at this point, we're just trying to understand our entities and how everybody works together so we can see that a part is on zero or more orders and an order must have zero or more must have an order must have one or more parts on it. So a part has zero or more orders, and an order has one or more parts on it. To actually implement these one to one relationships and one to many relationships, to implement the many to many relationships, we're going to have to do some fancy stuff, and we'll talk about that. But to implement a one to one relationship or a one to many relationship, we take the primary key of the one table and add it to the many table. We take the primary key of the one table and add it to the many table and mark it as a foreign key. It's a key that belongs to somebody else that's foreign to us, but it's used to implement that relationship. In the way that I'm going to do the diagrams, we're going to mark it with a little open parenthesis FK close parenthesis so that we can see that that's a foreign key to another table. If we go back to our animal species entities, we can see that I've added a new attribute to the animal table called species ID and marked it with the FK designation. So on the animal record, there will be the abbreviation for the species. And by using that abbreviation, we can then go down into the other entity, the species entity, and get the description that goes along with it. So if there is a animal with a code of E, we could then go down in the species, see that E is equine, and say and print out the so that connection is actually created. That connection is actually created by putting the primary key of the one table as a foreign key on the many table as a new attribute. So if we can do that for a one to many relationship and put the primary key of the one table on the many table, then it would make sense that here in this relationship we could put the customer ID as a foreign key on the order table. I've not done that yet, but we could put the customer ID as a foreign key on the order table and mark it as a foreign key. That way we can connect order and customer together. Makes sense. Now, connecting order and part. If we put the part ID on the order, then an order could only have one part, couldn't it? If we put the part ID on the order, then an order would only have one part. And if we had two parts on an order, where would we put the second part? Because we already put the, and vice versa, if we put the order number on the part, then we could have a part on one order, but a part couldn't be on multiple orders, so it wouldn't work either. So we can't just put a foreign key on the to connect the order and part together, because it just there's it feels like there's something missing. And guess what? There is. In a logical data model, we want to eliminate these many to many relationships. And to do that, we're going to have to create a new entity in the middle. We're going to have to create an entity between part and order, or we may have to create multiple entities. But in this example, we're going to create this new entity here in the middle. We call that an associative entity to resolve the many to many conflict. And also notice that the associative entity I've created called order detail now has a new attribute called quantity, because one order may order 5 of these parts, and another order may order 10 of the same part, and another order may order 1 of that part. So we need to track the quantity between the order and part, so that relationship also contains some data that we need to split out and store as an attribute somewhere. So what I'm going to do here is suggest that I create a table in the middle to eliminate the many to many relationship. Now, the order detail table you will see has a concatenated key of order ID part ID, which uniquely identifies it. Those two attributes that make up the primary key of the order detail are also foreign keys back to their one table. Um, we could have done that, or we could have added a surrogate key if we'd wanted to, but this I think is really slick. So let's go through and read the crow's feet and make sure that we understand all of the relationships. We can see that between customer and order, their customer ID is on the mini table and the as a foreign key, and the customer ID is on the customer table as a primary key. So a customer can have 0 or more orders, but an order is for one and only one customer. A customer can have 0 or more orders, and an order can be for one and only one customer. A part can be on 0 or more order details, and an order detail is for one and only one part. An order can have one or more order details, but an order detail must belong to one and only one order. So the order detail, think about an order. You think about an invoice, or think about a receipt where item number, quantity, item number, quantity, item number, quantity on one order. So that item number quantity repeating group is handled by this transaction detail entity. In our discussion of the conceptual data model, we talked about specialization and generalization, the has a relationship and the is a relationship. We talked about they come in exclusive and non-exclusive manners. For instance, a vehicle can only be a car or a truck or a motorcycle. It can't be multiple, where a person could be multiple roles um, in the specialization. In an entity relationship diagram, specifically the logical model and physical model, the IE style model, we're going to use a little symbol that's rounded on the top and flat on the bottom, and either has an X if it's exclusive or not. It's a different way of drawing it than we did in the conceptual data model, but once you see it, I hope it'll make a lot of sense. Here are the two shapes that we're going to be using to represent our specializations or generalizations. The non-exclusive specialization is the or symbol with the children and the parent going from the top to bottom, and the exclusive specialization is the same shape with an X in it, saying you can only have one of the specializations. Here's a specialization hierarchy where a person is a customer, a person could be a vendor, a person could be an employee, a person could be a donor. Maybe we're working here for a nonprofit, and these are the various roles that individuals have that we want to track in our database. And you can see the specialization hierarchy exists to say a person is a customer, a person is a vendor, a person is an employee, a person is a donor. Or actually, it's the other way around. A customer is a person, a vendor is a person. You can also see that the primary key of the one table, the primary key of the person table, is also a foreign key on the customer table, and attributes that deal with the customer are in the customer table, but the attributes that deal with the person as a whole, the common attributes across all of the specializations, are all up in the parent entity. Here's another example. Only in this example, we will see that the specialization is exclusive. So a person can own 0 or more vehicles. A vehicle is owned by one and only one person. We can see the person ID from the one table is a foreign key on the many table. We're using the vehicle identification number, or VIN, as the vehicle's unique identifier. Each car has got this big long serial number, and all the automobile and truck and motorcycle manufacturers all over the entire world have all agreed that none of them will ever give the same number out. They each have their own unique numbering sequence. So a VIN would be unique. Well, unless, of course, you're dealing in really old cars from the 1930s and 40s and 50s, and then there might be a problem, but we're not worried about that in the context of our little database here that we're modeling at this point. So we can see that a vehicle can be either an automobile, a truck, or a motorcycle. And we do have in the vehicle table an attribute that says vehicle type, and that would be either an A, T, or an M, so that we know which of the subtypes it happens to be. So the automobile table contains the foreign key to the vehicle table, because an automobile is a vehicle. A truck is a vehicle, a motorcycle is a vehicle, and the specific information about the automobile that makes it different than a truck, that makes it different than a motorcycle, um, are in these various tables. So you can see how this specialization hierarchy works, and there is a exclusive specialization hierarchy. Again, I'd like to say thank you for watching this video entitled The Logical Data Model. It's part of the Introduction to Database Systems Modeling and Administration textbook. I'm Dr. Reneau. If you found this video helpful, I'd love it if you'd like the video or follow or send a comment about what you think. And I appreciate you, and hope to see you in another video soon.